Hi guys, I said I'd do a reaction video. Let's do a reaction video. This video is from a channel called Up and Atom. It's called The Raven Paradox. Now I did already go ahead and watch the video because I'm not ready to do one of these cold. So I guess let's just get started.
Hi everyone, Jade here. What if I told you that the observation of a white shoe can support the hypothesis that all ravens are black? You'd probably think I was talking complete nonsense, right? And to be fair, that's a pretty reasonable response.
Now this looks like it's going to be one of those weird logic videos. So that's what I think is about to happen.
What could a white shoe possibly have to do with all ravens being black? Well, this is a video about a phenomenon called the Raven Paradox. It came about in the early 20th century when a hopeful group of scientists and philosophers were trying to understand the world. They called themselves the logical empiricists, and as the name suggests, they thought the only things you needed to understand the world were logic and empiricism, which is basically observations of the world we all agree on. In a nutshell, their philosophy was that any meaningful statement about the world could be understood by looking at the world. That's the empiricist part. And then we could use logic to make conclusions. The name the logical empiricists gave their way of understanding the world might be familiar to some of you. It's called the scientific method. And as
Okay, I gotta look this up. As usual, I'm gonna look at Wikipedia. Let's see, the central thesis is the verification principle, also known as the verifiability criterion of meaning. This theory of knowledge asserts that only statements verifiable through direct observation or logical proof are meaningful in terms of conveying truth value, information, or factual content. Starting in the late 20s, there were philosophers, scientists, mathematicians formed the Berlin Circle and the Vienna Circle, which would propound the ideas of logical positivism. Let's see, same name, different thing. Let's see. The movement was led mainly by Karl Hempel, who, during the rise of Nazism, had emigrated to the United States. In the ensuing years, the movement's central premises, still unresolved, were heavily criticized by leading philosophers, particularly Willard von Orman Quine and Karl Popper, who, since I did already watch this video, I can tell you their names are going to come up again. And even within the movement itself by Hempel, the 1962 publication of Thomas Kuhn's landmark book, The Structure of Scientific Revolutions, dramatically shifted academic philosophy's focus. Okay. Let's see. Let's look at principles. By reducing mathematics to logic, Bertrand Russell sought to convert physics mathematical formulas to symbolic logic. As usual, Wikipedia is way too complicated talking about all this. It's almost like we need a simpler version of Wikipedia. No, I'm not going to look it up on the simple Wikipedia. Alright, so near as I can tell, the whole point here is to just be as logically silly as possible.
As you can imagine, it's greatly influenced the way that we think about science. But things didn't go as smoothly as they imagined, as the Raven Paradox soon flew into the face of their neat little method. Hopefully, by the end of this video, you'll see that the ways that we go about doing science aren't always as straightforward as you might think. To demonstrate this, let's take inspiration from the logical empiricists and try to do some science with just logic and empiricism. Imagine you have the hypothesis, all ravens are black. It seems like a reasonable hypothesis to make, right? So, as a logical empiricist, what kind of steps would you take to investigate this hypothesis?
As you all know, I'm not a scientist, but I do have some ideas here. First of all, the hypothesis all ravens are black can be easily disproven by finding one, and only one, raven that is not black. So this is the kind of hypothesis that when I see it, I would be like, you need to qualify this. If you want to make it a theory or an accepted fact or something like that, you need to qualify it by saying, as best we know, all ravens are black. We haven't found any non-black ravens. As a side point, I guess one way you can tell that ravens are black is by the number of cops in America that are shooting them.
Well, to gather some empirical evidence, you could go out into the world and simply find some ravens. Check the color of their feathers and see if they're black. So you do this, and every raven you find is black. This is good news for your hypothesis. Logical empiricism tells us that with every new black raven you see, you should become more confident in your hypothesis that all ravens are black.
Now, she started out saying that a white shoe can prove that all ravens are black. And then we got this cool little animation here with all these ravens wearing shoes. I don't see any of them wearing white shoes. I wish she had come back to this because there's some possibility here, but the fact that they're wearing shoes turns out not to matter.
So now that we've gathered some empirical evidence, it's time to introduce some logic. Basic inference and deduction tells us that the fact that we've only seen black ravens supports our hypothesis that all ravens are black. We can formalize this logic by saying observing lots of A's with property B supports the hypothesis that all A's are B.
All right, again, the problem with the hypothesis where you say all of these things have the same property, we know this kind of thinking is dangerous. It's bad for your mental health, but it's dangerous in general. For example, in the 1930s, you might have said all Germans are Nazis. People watching America right now might think all Americans are batshit crazy. Neither of those statements are true, but what you see might lead you to believe that. I made a few videos about addiction recently. All addicts are whatever. There's a stereotype of alcoholics becoming violently abusive when they drink. The overwhelming majority of alcoholics do not become abusive nor violent when they drink. But compared to people who are not alcoholics, there is a slightly higher percentage of alcoholics that do become abusive or violent when they drink. But there are non-alcoholics who become abusive or violent without drinking. So this kind of hypothesis is always going to be a bad hypothesis. But let's go ahead and continue with this video.
We can replace A with raven and B with black, or we can replace them with anything for that matter, and that logic should still hold. Now we can use the rules of logic to change this statement in such a way so that it is logically equivalent. What I mean by logically equivalent is that there could be two sentences that look different on the surface but are really saying the same thing. For example, the two sentences, "I'll meet you at the cafe at noon," and "I'll see you at the shop which sells coffee when the sun is highest in the sky." One might sound a little bit weird, but ultimately they mean the same thing.
They do not mean the same thing. I like that she's trying to make this point, but I can think of several shops that sell coffee that are not places where you would sit and enjoy coffee with a friend. For example, I can go to the grocery store and buy coffee. I can go to a convenience store and buy coffee. A cafe is one of several different types of shops that sell coffee. And of course, in America, we would generally call it a coffee shop or coffee house. We don't really call them cafes, but whatever. So this point isn't really going to stand, but I will go ahead and stipulate. I will go ahead and stipulate that you can rephrase something and have it still be logically equivalent. However, as a writer, I feel obligated to point out that the reason you rephrase something is you're usually looking for subtle differences in meaning. That's why you rephrased it in the first place.
They're logically equivalent. To make this clearer, it's often really helpful to draw Venn diagrams to help visualize what we're saying. Let's draw a circle to represent all black things, and another disconnected circle to represent all non-black things. Remember, our original hypothesis is that all ravens are black, which means that, assuming our hypothesis is true, ravens only exist in the all black things circle. But if we stop and think about it for a second, we can see that it's logically equivalent to say that there are no ravens in the non-black circle, or in other words, all non-black things are not ravens.
All right, I'm having trouble with this logic. She is saying two different things, but I'm really having a hard time putting my finger on what the problem is here. I guess we'll just go ahead and continue. Maybe it'll come to me.
All ravens are black is logically equivalent to saying all non-black things are not ravens. If you're not convinced, take a bit of time to let this sink in, because this should be a non-controversial statement.
I'm still not convinced. She's right, it should be non-controversial, but the statement, all ravens are black, that's an active statement. You're specifically talking about ravens, but when you say all non-black things are not ravens, you're talking about non-black things. You're not talking about ravens. I feel like Edgar Allan Poe would have something to say here. Yeah, I think that's my problem. You changed the subject. In the statement, all ravens are black, you're talking about ravens. But in the statement, all non-black things are not ravens, you're talking about non-black things. So you're talking about two different things, which means they're not logically equivalent. They don't mean the same thing. There's a difference in meaning here. Now, you evaluate them logically and they come out similar, because it does make sense that if all ravens are black and you have something that's not black, it's obviously not a raven. It can't be a raven if all ravens are black. So they're similar, but there's a subtle difference in meaning here because you're talking about different things. I'm not sure if it really applies to the paradox she's presenting, but this looks like some fuzzy reasoning to me.
Now, can you think of a non-black, non-raven? Well, what about a white shoe? It fits the description. It's not black, it's white, and it's not a raven, it's a shoe.
Now, remember at the beginning, she said something about a white shoe proving that ravens are black. I hope this is where she's going to drive this home, but I can kind of see where it's going.
Now let's apply some inductive logic. Take the same formally logical statement from before. Observations of A with property B support the hypothesis that all A's are B. We can replace A with non-black things and B with not ravens. So the observation of a white shoe gives support to the statement, all non-black things are not ravens. But hang on a minute. We showed that the statement, all non-black things are not ravens, is logically equivalent to the statement, all ravens are black.
Okay, I guess one of the issues I'm seeing is that there are also black things that are not ravens, which is obviously not something we're talking about, because if all ravens are black, then there are lots of other black things that are in the same circle of black things, from the beginning, from earlier. Ravens are just in that same group with all the other things that are black. Anyway.
So we can swap it in without changing the meaning of the sentence. And what do we get? An observation of a white shoe gives support to the hypothesis that all ravens are black.
All right, so that word support is doing a lot of heavy lifting here. Remember, if you want to prove that all ravens are black, you basically have to observe every single raven that has ever existed and will ever exist and see that every single one of them is black. If you can find any raven that is not black, either currently alive, not currently alive, then the hypothesis is gone. It's disproven. You have to change it to most ravens are black. But observing something that is not a raven that's not black doesn't say that all ravens are black. All it says is that something else that is not a raven and is not black is not a raven. There is a strategy you find, you see this in math, and you see it a lot of times in sciences, where in order to prove something is true, you try to prove that it's false. Saw this in calculus a few times. Whenever you look at proofs like this, there's always a point in the proof where you wind up reasserting whatever it is you're trying to prove is false. And you can't just pick something else and prove something else is true, and that somehow disproves what you're trying to prove. Like this whole ravens thing. A black shoe is also not a raven, but it says nothing about ravens being black. So a white shoe not being a raven also says nothing about ravens being black. It just says something about shoes.
Now, I don't know about you, but I don't remember the last time a bird scientist published their results on the observation of white shoes. And I like to keep up with my bird science. But all we used to construct our argument was logic and empiricism, so what went wrong? This is the question that puzzled philosophers of science for years and still does today.
All right, I'm curious why they kept that in. I usually jump cut when I screw up when I'm talking, but, other people can make their own
There are many responses to the paradox, but here I'll give the 3 most well-known ones. And who knows, they may even inspire you to come up with a theory of your own. One potential response, which our logical empiricist friend Carl Hempel actually gave, is to just bite the bullet and say that an observation of a white shoe does help confirm the hypothesis that all ravens are black, even if only by a minuscule amount.
Now, you notice how she said, even if only by a minuscule amount. I'm going to go with no, we can't accept that one, because the observation of white shoe says nothing about ravens. If you want to prove anything about ravens, you need to be looking at ravens. The only reason to look at anything else would be to compare. And in this case, you would want to compare it to other birds, possibly other animals. But shoes are neither birds nor animals, so looking at a shoe says nothing about ravens.
End of story. The advantage of this response is that the scientific method stays safely intact and there is no paradox. But it doesn't really gel with our intuition of how the world works.
Now, It's interesting here because I remember learning about relativity. Maybe you don't know this, but back in the day, this is where the name Vulcan comes from in Star Trek, actually. Back in the day, before relativity was discovered, and they were studying, astronomers were studying the orbits of the different planets. I believe they'd already discovered Uranus. They were watching Mercury's orbit, and Mercury's orbit was wrong. Under Newtonian physics, or mechanics, Mercury was in the wrong place. And so they hypothesized the existence of another planet. I don't remember if that planet was closer to the sun, like between Mercury and the sun, or if the planet was farther out. But they named that planet Vulcan, and they proved where it had to be mathematically based on Newtonian mechanics, and they were unable to observe it. And then later, after relativity, somebody went and crunched the numbers and determined that under relativity, Mercury was actually in the right place because of how the warping of space-time works when you're that close to a huge mass like the sun. I forgot where I was going with this. Hang on.
This response is that the scientific method stays safely intact and there is no paradox. But
so what I'm saying with the example of Mercury is that by observing Mercury's orbit and seeing it was in the wrong place based on what we knew at the time, the scientific method wasn't challenged. None of the previous work that anybody had done was significantly challenged. The question was, if there is no planet Vulcan, what do we not know that we need to know? And that's being left out of this Raven paradox question, at least the way she's presenting it, is if you observe a bird that looks like a raven that's not black, but you believe that all ravens are black, what is it about this one bird that looks like a raven but isn't black? First of all, is it actually a raven? Or is it just a bird that has evolved to look very similar to ravens? I mean, the scientific method doesn't collapse just because you have an observation that doesn't fit previous observations. Contrarily, the scientific method is strongest at that point because it helps you to understand that that means you don't know something that you thought you knew, and you need to look further, which of course is what happened with planet Vulcan and Mercury. And so now Vulcan is a fictional world nearby that has the pointy-eared logical people on it who would probably have a lot to say about this video.
it doesn't really gel with our intuition of how the world works. Philosopher of science Nelson Goodman said that if this approach were true, we could do a lot of indoor ornithology. In other words, we could sit in comfy armchairs and further the study of birds by pointing at colourful objects. Not only that, but if you think about it, an observation of a white shoe also helps confirm the hypothesis that all ravens are blue, or green, or purple. Let's see what other options there are.
You see how easily that one was taken down.
The next response comes from another famous name in the philosophy of science, Karl Popper. His approach to science can basically be summed up as: the job of science and the scientific method is to show whether or not a hypothesis is wrong. That's it. This idea of showing something as false using observation is called falsifiability, and it's what Popper thought was the key feature of a scientific hypothesis.
Now, I generally agree with this. The problem is you can't actually, there's so many things you can't learn this way. Like Newton's second law, force is mass times acceleration. Okay, what if you said force is 2 times the mass times acceleration? A lot of observations would support that, but if you sit down there and you do the math, you take the measurements and you do the math and you prove that that can't possibly be true, fine, you disproved that. But how do you get to force is mass times acceleration? How do you get to that if all you can do with science is prove a hypothesis wrong? But there's a lot more that goes into formulating a hypothesis than simply, I've only ever seen black ravens. I think all ravens are black. There's more that goes into forming that kind of hypothesis. But it is worth pointing out right now, when I had kids and they're growing, they start as babies and they're growing. And at some point while they're still babies, one of the developmental milestones you're looking for is use and application of the scientific method, because you don't need the rigorous formalized version of the scientific method to function. It is actually such an important way of learning things that we do this naturally, and we're looking for it. I want to say it's around 8 or 9 months in babies to see if they have developed that, because if they haven't, we could be looking at some kind of neurological issue or developmental issue or something like that. And so if you ever wondered why babies sitting in a high chair keep throwing the spoon, that's why. They formulated a hypothesis and they're testing it.
On the surface, this seems like a reasonable way of looking at science. It always leaves us open to the possibility that we might be wrong. But if we look a bit closer, things get a bit funny. Remember when we said that many observations of black ravens would support our hypothesis that all ravens are black? Well, Popper completely disagreed with this approach. He thought the business of science was to falsify theories and only falsify them, not make us more confident in anything being true.
All right, this is definitely wrong because this is how we've been testing relativity and evolution in particular. There are a lot of predictions made by both of these theories, and this is how science works. You come up with a hypothesis, you come up with predictions that, if true, your hypothesis will predict these things, and then you look for those things. And the more of those things you find, the more your hypothesis looks true, and the more of a theory it becomes. So one of the biggest examples I can think of with relativity anyway, because believe it or not, I know a few people who don't think relativity is real. But one of the biggest examples is in your GPS, your mapping software. If you actually look at the algorithm used, because the way GPS works, the satellites don't tell you where you're at. They tell you where they're at. And then the software takes that information and figures out where you're at based on where the satellite said they're at. Because of how fast they're moving, and because of the gravity well they're moving in. Relativity, those field equations make their way into that algorithm one way or another, and you can't avoid it. Time is passing differently for the GPS satellites themselves because of how fast they're moving and where they're moving at than it passes for you receiving the signal. And if relativity wasn't true, none of that would matter.
An observation of a white shoe wouldn't support the hypothesis that all ravens are black, but neither would a black raven. To Popper, the notion of support or confirmation was not the way science should operate. If all we find are black ravens, all this means is that our hypothesis is yet to be falsified.
Again, they're missing an important point here, which is that in order for a hypothesis to be true, it has to predict something. Like, there is no theory in science that's useful that has no predictions. Going back to Newton's laws of motion, without Newton's second law, it predicts things like when you fire a gun, where's the bullet going to go? You fire a cannon, where's that going to go? Rockets. There is so much built on the predictive value of a theory. This is what engineering is. You take all this sciencey stuff and math and stuff, and you figure out how to build something. And without the prediction abilities, you wouldn't be able to do any engineering. Proving something is true or false in science, while that is obviously really important, if you're trying to prove something that doesn't predict anything, you're wasting your time because it's the predictions that matter. To that point, that's how you prove or disprove something, or you narrow the scope of when something is true versus when it's not. So, for example, the whole thing about Mercury's orbit, that didn't disprove Newton's laws of motion and his law of gravity, and then Kepler's laws about planetary orbits. That didn't disprove any of that. Instead, it says you also have to be a certain distance from a significant mass for these equations to work. When you get closer, you need to use these other equations. And scientists still use the original, Kepler equations when they're observing exoplanets. They still use those, but they do need the more complicated ones, like for the TRAPPIST system. I'm pretty sure they have to use relativity-based equations because those planets are also close, not just to the sun, but to each other. But the point is, the primary way we look at proving a hypothesis is to prove the predictions. If the hypothesis predicts something, and then we see that thing, that tells us the hypothesis is probably right. If we don't see that thing, then maybe the hypothesis is wrong. But if the hypothesis predicts, say, 5 things, and we see 4 of them, then the hypothesis is right. But if we see the opposite of the 5th thing that it predicts, then we say the hypothesis is right for those 4 things. And then we look at the 5th thing and we ask, what's special about it? Why is this one different? Why is Mercury where it's at, even though it should be somewhere else? And there's no other planet there. And that's how we find out that there is something we don't know.
This last response, I must tell you, is the one I agree with most, just so you know my biases up front. It has to do with the context.
Yeah, you should have said it up front if you meant it to be known up front. Just pointing that out.
Surrounding an observation. Let's demonstrate this with some strange but instructive examples. Imagine you have someone come up to you and say, "Behind my back is a raven. Would you like me to show it to you?" You're a bit creeped out, but as someone interested in the hypothesis,
I like how she's still pointing out, you're a bit creeped out. Someone just walked up and said, "Hey, I'm holding a raven. You want to see it?"
all ravens are black, you should say yes, since if it's a blue or purple raven, that would refute your hypothesis. Popper would be proud.
Okay, take a moment. What color is the raven? Someone says, "I have an object behind my back." If it's a raven, you want to say yes so you can see if it proves your hypothesis. Or you can make a prediction and say, if that's a raven, it's going to be black. Now show me the thing. Remember, predictions.
Now imagine someone comes up to you and says, "Behind my back, I have a black object. Would you like me to show it to you?
Again, if you're trying to prove all ravens are black, you have to first predict the object. If it's a raven, or if it's black, it might be a raven.
You figure the people here are just a bit weird, so you go to say yes.
They are a bit weird, but I want to go there.
But if you think about it for a minute, whatever is behind their back could never refute the hypothesis that all ravens are black. Since even if it is a black raven, not much would be learned since you knew the object was going to be black given the circumstance. Finally,
Well, now, if only ravens are black, and the person comes back and say, I have a black object, and you want to prove that only ravens are black, you predict that they're holding a raven, but that's not what she's trying to prove here.
a more subtle example. Imagine a third person comes up to you and says,
I like this person. I just want to say, I like this person. What, Swamp Thing? Something like that? Got bowling ball holes on his face?
behind my back is a non-black object. Would you like me to show it to you? Here, you should definitely say yes, since it could be a blue raven, which could refute your hypothesis. But if this person pulls out a white shoe, in a roundabout way, it gives support to your hypothesis that all ravens are black, since given the particular situation, a different outcome could have refuted it. But the crucial point to make here is whether or not we care about the observation of a white shoe depends on the wider context. If this person said they have a non-raven behind their back, then pulling out a white shoe should not matter to you in the slightest, since we only care about ravens, whereas you should care if they say they have a non-black object, since then it has the chance to be a non-black raven. So the takeaway with this response is that sometimes a white shoe does add confidence to your hypothesis, and sometimes it doesn't. You need more information about how the observation was carried out to make that call. So they're just 3 theories about how the Raven paradox could potentially be resolved. The historical development after the advent of the logical empiricist was incredibly fascinating, with its fair share of heated disagreements and skirmishes between scientists and philosophers.
You know how scientists and philosophers fight each other? Philosophers gather in groups and have debates, and then scientists blow them up.
Some had more radical approaches to the scientific method, like Paul Feyerabend's total rejection of any kind of universal methodology, complete scientific anarchy. Other approaches, like Bayesian analysis, were developed and are still being widely used to this day.
I love Bayesian analysis. There's another guy at another channel. It's like 3 blue, 1 green or something like that. 3 blue, 1 brown. He does a lot of Bayesian stuff. You should check it out.
But that is a topic for another video. What the Raven paradox tells me personally is that you can't remove science from the specific context in which it's done, even in principle and especially in practice. I think this paradox...
Okay, I'm going to disagree with that one. To some extent, you can't remove the science from context. And everybody wants to bring up Galileo at this point. And there's an ongoing question, why did Galileo get the shaft from the church when Copernicus didn't? Copernicus basically said the same thing. Galileo was confirming Copernicus's work. The reason Galileo got the shaft had nothing to do with him deciding the sun was at the center of the solar system, and everything to do with the way he talked about the Pope when he was talking about it. He criticized the Pope. Copernicus didn't. That's the context here. We throw away the context in some kind of effort to talk about how the establishment will always pick on the revolutionary new scientists. No, Galileo was revolutionary, but not with his discussion about whether or not the Earth or the Sun was at the center of the solar system. He was revolutionary because he used his pulse to time objects that he dropped from the Tower of Pisa, and that was the first time time was introduced as a variable in physical concepts. That was what he revolutionized, in case you were curious. What was I talking about again? Right, science and context. Because if you retain context, then there's an ethical argument for not using relativity anymore, because Einstein was sort of involved with the atomic bomb development. In fact, relativity is what made it possible. Well, it's one of the theories that came out around the early 20th century that made it possible to build the atomic bomb in the first place. That context is important to understand history and to understand how science can affect real events in the world. But there's a certain universal truth to be found here also that doesn't require humans at all. Stars are going to warp space-time around them whether we see them doing that or not. You know, the old philosophy question, if a tree falls in the forest and there's no one around to hear it, doesn't make a sound. Yes, it still makes a sound. It makes a sound whether or not there's anything to hear it, because things that happen are still going to happen whether anybody sees it or not. So kind of the point of the scientific method, like the primary point of the scientific method, is to work through all of these biases that we have. When you go to treatment, you study cognitive distortions, all those distorted thoughts, they are logical. And you can use logic to prove other things based on them, but they're still distorted. There's no universal truth there. In order to get to universal truth, you do things like check the facts. You do things like you ask someone else, hey, did you see that? Hey, did you see it? And when enough people see the same thing, then we can say that thing definitely exists. So philosophically, I mean, I could argue I don't know what's real, because everything that I can actually see and hear is a construct in my head being built by my brain. I need you to tell me if it's real, but not just you, because you could be hallucinating the same thing. I need several other people, you know. So taking science out of the context in which it was done, is actually important, because if the only place that a particular scientific theory is true is, for example, when you're in a mental hospital, then it's probably not true. And this is separate from putting constraints on when a particular theory works versus when it doesn't. So, for example, the Newtonian mechanics example I gave can predict all of the orbits of the solar system from Venus out, but it cannot predict Mercury. That kind of constraint isn't what I mean about context. Like, if you want to look at actual context, look at what Isaac Newton actually did with his life. You notice I'm not calling him Sir Isaac Newton. He was knighted because of work he did to track down counterfeiters. He wasn't knighted for his scientific work. So in a scientific context, he is Isaac Newton. He is not Sir Isaac Newton. This is important because as a scientist, he was also trying to turn lead into gold. He was an alchemist. All the science we got from him was stuff that he did in his spare time for fun. His primary pursuits were crap. He was a crackpot. He was also a very deeply devout spiritual person who, by all accounts, the reason why he never married or even had sex was because he didn't consider that a pure activity for him to pursue. If you take that context and with our modern judgments decide all the science he did must be crap because of that, maybe I'm missing the point. I probably am. Let's see how she finishes concluding the video.
Paradox serves as a really good introduction to the counterintuitive intricacies of the scientific method. It challenges our assumptions about how science is done, and in doing so makes us understand it and hopefully appreciate it all the more. But I want to know what you think. Does the observation of a white shoe support the hypothesis that all ravens are black? Let me know your thoughts in the comments below.
Okay, I'm going to answer a question in this video. No, observing a white shoe says nothing about ravens. I guess it answers the question. I'm curious how big of a deal this paradox really was, historically speaking, because I find there's something else she said about the scientific method challenging us. I don't think the scientific method inherently provides any challenges because it is a natural development. You know, like I was saying, we think scientifically, whether you like it or not. You do think scientifically. And that's different than a rigorous definition of the scientific method. Science was done for thousands of years before we had a rigorous scientific method that we use now. And a lot of that science, it's still important. Archimedes' law for buoyancy, all of trigonometry was developed, way before we had a rigorous scientific method. There's a whole lot of chemistry that was done, like Faraday, I think Tesla. So it doesn't inherently challenge us, but when you're studying something, you're observing, you're taking your measurements and so forth, and you find that it doesn't fit, you find something that doesn't fit what we already know and understand, there is a challenge there to determine what exactly you're looking at. But the scientific method doesn't impose that challenge. That challenge is already there. It was there before we had a formalized method or anything. I really think that, and I'm someone who generally tries to live like I treat it almost as a religious doctrine, except I don't have dogma. I really think scientific thinking and the basic idea that you can see something and it's true for you is true, but in order for it to be true for everybody, you need more people to see it. I ran into this recently with a person who said they saw a UFO out on the horizon. And I looked and I was like, no, it's an airplane. I happen to know there's an airport down there. I recently looked at a map and found that there was an airport closer too that I didn't know at the time. It's a smaller airport. Anyway, so I can see that it is true for her that she saw a UFO and thought aliens. But me, and later during a similar conversation where there were other people present, other people looked. She was the only one who saw the aliens. The rest of us saw airplanes and stuff. We also saw some lights moving around that we didn't know what they were, but didn't have a reason to jump to aliens. So what can be challenging about the scientific method is setting aside the biases that we have internally, because it's so easy to listen to those and to just take the world as it is, filtered through our own thoughts and feelings. And it's really easy to get off track when that's how you see the world. And it's kind of weird that we started with a silly paradox and ended there, but that's what happened. That's the video. It's my first reaction video. If you have anything in particular you'd like to say, there are comments down below. You can make that there. Of course, if you have a specific question for me, you can go become a patron on Patreon, link down below. Ask me there, and then I will answer it in a video. So until next time, bye guys.